Vectors in R3 space. Coordinates of point F equals to 3, 5, 2. So we're basically given R3 space, so we have x-axis, y and z-axis here. Point F is right there, which is 3, 5, 2. It means from origin, which is represented as D here, move 3 units towards x, 5 units towards y, and 2 units along z. So that gives you point F, and that is 3, 5, 2. So let me write down 3, 5, 2 right here as the coordinates of point F. Now let's answer the questions. First one is, determine the coordinates of point C. So we need to find coordinates of point C, which is right there. Now as you can see here, from the origin, we have to go straight to C, right? So 0 along x, 0 along z, right? So the coordinates of C should be 0. And this line is 5 units away, right? Since this is on this rectangular prism, right? So y value is 5 and z value is 0. So that is the coordinate for point C. So we can write this here. Coordinates are 0, 5, 0. Determine the vector DE. That means from D to E. So we need to now find the vector from D to E. So since D is origin, let me write O as another point. Origin, D is kind of position vector, right? So let's figure out what is the coordinate for point E. Now to reach E, what should we do? We have to go 3 units along x, right, to reach at A, and then don't move along y, that is 0. So it is 3, 0, and then 2. So that is the position, right? So we can write this as 3, 0, and 2, right? It's a good practice to use square brackets to show the vectors. Okay, so it is DE vector, right, is 3, 0, 2. Determine the vector AG. Now AG means from A to G, right? So that is the point A for us, and this is G. Now let's first figure out what are these two coordinates, and then we'll find AG. Coordinates for A are, along x it is 3 units. That's it. And for G, it is how are we going to reach Z. So we go along x, we have to go 0 units. We just go straight here along y and then up along z, right? So it is 0. And then along y, 5 units and 2 units along z. So that is the coordinate for G. So vector AG will be equal to difference between these two positions, right? So 0 minus 3 will give us minus 3. So we get this as minus 3. 5 minus 0 will give us 5. And 2 minus 0 gives us 2, right? So that is how we get the coordinates for G, right? It makes sense. See how? So if you see, if you have to go from A to G, right? So from A you move 3 units to the other side. That is minus 3. Do you see? Minus 3. And 5 units along C and 2 units up. So that gives you the vector AG. I hope you understand that part, right? So this is how you get your vector AG. Now part D is determine the equation of the plane BFGC. So this shaded plane is the BFGC plane. You have to give equation for this particular plane. So how are you going to write equation for this plane? Well, as you can see, every point on this plane, we have seen a couple of points, right? All of them has one common value, and that is y, right? So y value is 5. So we can write this plane as y equals to 5, right? So this is a plane which extends along x and Z, right? So this is parallel to this plane, correct? But 5 units away on y. So y equals to 5 represents the plane BFGC. So that is the equation for our plane, right? So that is how we can understand R3 space, right? So what we have seen here is how to get to a point 3, 5, 3. Let's go back. 3, 5, 3. There you are. Coordinates of any point. So let's say if we want to coordinates of H, for example, then we don't move along X and Y, straight go to Z. So it is 0, 0, and Y, Z coordinates is 2, like that. If you need vectors in this, for example, OE, since O was the origin, E represents a position vector. So the vector is difference of position of E minus D, right? That is the difference, like we did for AG, right? And then for a plane, we have to see, if we are talking about this plane on the top, this is parallel to X and Y, and therefore it will have a fixed value for Z, and Z equals to 2 will be the value of the plane, which is represented by EHGF. That is how you can get equation of plane, vector, points, everything related to one coordinate point. I hope you appreciate that part. Thank you and all the best.